Good day. This is a second video that we're making on a typical word sum where we use everything we know about the parabola to solve this word sum. It's also sometimes called applications. To see more of these type of questions, you just type parabola word sum application and you'll find more. In this specific video, we're going to use 4 different ways of solving this problem. The first one, according to me, is the easier and the one that you should use, but there will be 3 short explanations at the back with 3 more ways of answering this question. When doing a word sum in maths, I would advise you to always read it 3 or 4 times. So stop this video and read this whole question on your own. I will run through it quickly with you. It says here, a cannon is standing on a 6-meter cliff. A soldier shoots a cannonball at the bird flying 15 meters above the sea. The height of the cannonball above the sea in meters for the time that the cannonball is in the air in seconds is given by the equation, and then this is h of t is equal to minus 5t squared plus 5, 10t plus 6. This you can read yourself. The question is it possible for the soldier to hit the bird? Show all your calculations to support your answer. I'm going to show you 4 different ways. To me, the first method is the best, but it all depends on you. Now back to this problem. Usually in a good question like this one, they would give you a small picture that you can see how the word sum and what it means in the word sum. They said that the cannon is 6 meters above the sea level, so the cannon is standing 6 meters high already. The bird is 15 meters in the air. They show us this parabola over here. And they give me the equation of the height of this ball being shot. So the ball will go along this line. We know this is an equation of a parabola because of the t square that we have. And the last important thing to remember is that this is the height of the cannonball above the sea. So this answers we're going to get is above the sea level. It's got nothing to do with the cliff anymore. When I answer a word sum like this, I always take the picture that they give me and put that on a Cartesian plane in the first quadrant. This is my y-axis, my x-axis. There, the cannon would have stood over here. The highest place of my parabola is over here, and I draw my parabola in here. Put my north at the bottom here, and I write my equation down. The equation said it's h of t equals to minus 5t squared plus 10t plus 6. Not very important, but they told me that h will be the height of the ball in meters, and t will be the time in seconds. It's very much the same as when we wrote the equation like this, y equals to minus 5x. You can change this to y and x if you want to. So your height will be your y values and your t will be your x values if you want to look at it that way. The problem said that the cannon is 6 meters above the ground, so it's 6 meters already in the air, the ball, before it gets shot. Then there's a bird in the air. We know it's 15 meters high, and we don't know how far it is from here. And we know that the water is at the bottom here. My job is to work out the maximum turning point of this parabola and to see if the height that I get is above 15 or under 15, and then I'll know if I can hit the bird. Now to work out the maximum turning point or the minimum turning point of any parabola, you can either do it by completing the square, which we'll do later, or we can use this formula, minus b over 2a will give you the x of your turning point. You substitute that back in there to get the y of your turning point. I wrote here y or h, all depends what your brain is working with now. Right, I'm going to work with this formula, minus b over 2a, get the answer and plug it back in here to get the y of my turning point. Then see if that turning point is above or under that bird. Firstly, I got my a from here is minus 5, my b from here is plus 10, and my c from here is 6. Then I plug it into this formula. So my x of my turning point will be minus b over 2a. I took these numbers, plugged it in here, got my answer, and got the final answer is 1. So the x of my turning point will be 1. So after 1 second, the ball will be at its highest. Then I take this 1 that I just worked out, and I plug it back into my original equation. So I wrote h of 1 equals, put a 1 everywhere in the place of t, and my answer will then be 11 meters. I just rewrote it here for us. Our turning point is minus b over 2a and whatever the y value is. So then the answer is after 1 second, the maximum height will be 11 meters. This bird is 15 meters up in the air, so the ball will never go higher than 11, so it can't reach the bird. Now remember, when you finish with the word sum, you write the word sentence as your answer. So then we will write, the maximum height is 11 meters of this ball, so it can't reach the bird. The second method how to solve this problem, the best one, but very few people understand it properly, is to do completion of the square to find whether this is a maximum or minimum turning point that we have over here. So we take this equation and do completion of the square with it. If you understand completion of the square, stop the video and just check what I did here. Here, I changed the equation to the completed square technique. So this is just written in another way, and I've got my turning point plus 1 and plus 11 here now. So after 1 second, my height will be 11 meters above the water, and that means the bird is too high above the water. Technically, you should now write down this step to say that this equation is smaller than equal to 11, but we just write the answer, no solution for the height of 15 meters. The third method is to go through nature of the roots, not looking at the picture at all, not looking at the parabola itself. You take the equation, you write 15, the height of the bird equals, and the equation, you make everything equal to 0. Then you write out the formula for delta, and you work that out. That shows you the answer is negative 80. Then you write no solution for the height 15 meters. This is the worst technique. Then if you do get this question in grade 12, you can go through the first derivative to find the turning point. So you take your equation, this is just for grade 12, so you can take this equation, work out the first derivative, equate it to 0, and solve for t, which is then your x of your turning point, and you plug that back in here and get the y of your turning point. You get the same answer. After 1 second, the maximum value will be 11 meters. Please indicate whether you liked or disliked this video and subscribe to the channel. You can also send a request to this number by WhatsApp about anything that you're not sure about in school mathematics. We will make a video and post it for free on this channel that other people can benefit from your question.